For your quizzes and your test, I will not be doing quiz problems or giving answers. Alright, starting with 8.1 to 8.2. The polygon interior angles theorem says that the sum of the interior angles of any polygon formula is n, meaning the number of sides, minus 2 times 180. Okay, now you might want to draw a picture of this on your theorem list. I would suggest a picture that looks something like this. Draw a polygon, and then draw your angles, maybe with a different color. Okay, now remember, the picture is so that you can find what you're looking for when you're working your problems. So when you're thinking about adding up or finding the sum of all of those angles, this might help you to see that this is the one you're looking for. Okay, so I'll bring that in a little bit closer for you. And then somewhere close to that, you could put n minus 2 times 180. And remind yourself that n is the number of sides. Okay, so the corollary to the polygon interior angles theorem is, because we use quadrilaterals so much, they're going to tell you that for every quadrilateral four-sided figure, the sum of its angles is 360. So at this point, you might want to draw a quadrilateral. I wouldn't make it look like any particular quadrilateral if I were you, because you would think it was only for that kind. So any quadrilateral, and then I would put in there a plus sign and equals 360. Okay, that's for any quadrilateral. Now you can pause this presentation at any point on your computer so that you can write down whatever's there, so I can just keep moving. Alright, now the polygon exterior angles theorem says the sum of the exterior angles of any polygon is always 360. Alright, so what you want to do there is draw yourself a polygon. Don't draw a four-sided polygon or you'll get confused over whether it's just for quadrilaterals. And then you're going to need a different color so you can show which angles we're talking about, because you might forget what an exterior angle is called. Or what it looks like. Not what it's called, but what it looks like. Okay, those are your exterior angles. Now, because we don't want to get confused with the interior angles, I'm going to write the sum, or plus, is equal to 360 degrees on the outside. I don't want to put it inside the figure because I might get confused over which angles I'm talking about. Okay, now it doesn't tell you that if you need to find a specific angle, you're going to have to divide by the whole number of angles, or you're going to have to add up the rest of them. You're just going to have to know that. You cannot put that on your theorem list. Alright, I'm going to go to a new sheet because these are repeated. Okay, new theorems from 8.2 and 8.3. Now, the one going forward, saying if it's a parallelogram, okay, starting over here, if the quadrilateral is a parallelogram, both pairs of opposite sides are congruent. That's found in 8.2. Okay, on page 515. But then in 8.3, it tells you, oh, and by the way, if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So rather than writing everything twice, let's just write it one time with a double arrow in the center. And then I have put a picture with each one. Okay? So if both pairs of opposite sides are congruent, the quadrilateral is a parallelogram. Here's a picture of that. Oops. Okay? And this one says if both pairs of opposite angles are congruent, then it's a parallelogram. And again, you can stop and copy these down, or you could email me and ask me to send you the whole presentation. I can do that. You can find them right there in the book on page 515, and then again on page 523, 522, it goes through them again, only this time they have them going the other direction. So 515 starts over here with the quadrilateral as a parallelogram. Both pairs of opposite angles are congruent. And then on page 523, it tells you that if both pairs of opposite angles are congruent, the quadrilateral is a parallelogram. So it goes both ways. Okay, if one pair of opposite sides are both congruent and parallel, the quadrilateral is a parallelogram. And if the diagonals of a quadrilateral, make sure you realize it's quadrilateral, bisect each other, then it is a parallelogram. And if it's a parallelogram, the diagonals will bisect each other. That doesn't mean they're all the same length, though. Okay, moving along. Okay, theorems on page 533 and 35. A parallelogram is a rhombus if its diagonals are perpendicular, and a parallelogram is a rhombus if its diagonals bisect its angles. Okay, now it's very important for you to use that word if it's a parallelogram is a rhombus, because there are other figures that are not parallelograms that have diagonals that bisect each other, bisect its angles, or some angles, and the diagonals are perpendicular. And here's a picture of that. Okay, I've included both of those items on the picture. Okay, we can skip this one because I've got it down below. There's a corollary on page 533 that says a quadrilateral is a rectangle if it has 4 right angles, and also if it has 4 right angles, it is a rectangle. Now you may say, well, a square has 4 right angles, and a square is a rectangle. Okay, not all rectangles are squares, but all squares are also rectangles. But then you've got this corollary of the square. It's a square if it's a rhombus and a rectangle at the same time, because the rhombus gives it 4 equal sides, and the rectangle gives it 4 right angles. Okay, also on page 535, a parallelogram is a rectangle. A parallelogram, and it needs to be a parallelogram, is a rectangle if it has congruent diagonals. Now you need this word parallelogram there because trapezoid, the isosceles trapezoid, also has congruent diagonals, but it's not a rectangle. Okay, again, you can pause this whenever you need to, so you can copy stuff. Alright, some theorems about isosceles trapezoids. Now all of these begin with a trapezoid. Okay, if it's a trapezoid, it would be isosceles if its base angles are congruent. And if it's a trapezoid and its base angles are congruent, trapezoid, that says trapezoid, its base angles are congruent, then it's isosceles. If it's a trapezoid and its diagonals are congruent, then it would be an isosceles trapezoid. If it's a trapezoid and a pair of base angles is congruent, and a pair of sides are congruent, then it's isosceles. Okay, they go both ways, so you only have to write them once, and that makes more space for you. Okay, the mid-segment theorem is also in your book and given as a formula on page 544. I rarely get to use white, so I will use it now. Okay, and it gives you a formula, and the formula looks like this. It says 1/2, and if this had letters A, B, C, D, it says, oh, and then this is M, N, and it says Mn is equal to 1/2, times AB plus CD. Okay, so there's your formula. Now it says the mid-segment theorem for trapezoids is, if it's a mid-segment, it's parallel to both bases, so Mn is parallel to both bases, and it's half of their sum. which is what an average is. Okay, now we're going to go on to kites. A quadrilateral is a kite. If it is a kite, then it has exactly one pair of congruent opposite angles. Okay, and we have a picture of that. And if a quadrilateral is a kite, then its diagonals are perpendicular. Now, the definition of a kite is not a theorem, and you cannot write the definition in your theorem list. The definition of a kite is it has two pairs of congruent consecutive sides. AC and CB are consecutive because they're right in a row and they're congruent. Okay, make sure that you have updated your theorem list before you start these quizzes and before you take your test. All right, coast is clear.